And we're live. As you see written on the board, you'll have your next test on Thursday, covering up to and including lesson 44. We're working our way up to the midterm, so let's make sure that we've got things down. Start with any problems from problem set 47 that you want to go over. Number one, yes. All right. The defense budget was spent on halberds and other armor in the ratio of 2 to 19. If the total budget was 84,000 farthings, how much went for halberds? Now, so this is a ratio problem. How can we set up the ratio here? Well, what information do they give us? First, let's get the information that they give us. Please pick your heads up. Do some jumping jacks. Yeah. How do we write this out? How do we write out this ratio information?
2 over 19.
Okay, 2 over 19, but we set that equal to something. Equals what?
Oh yeah, what do you have to want? That's not one.
We're literally working on it right now.
21 over 84,000.
No. 2 to 19. What is 2 to 19? Look at the problem. What is that?
21.
Halberds to other armor.
Right, that's halberds to other armor.
What are houses?
Halberd is it's like a spear with an axe head on the end.
What?
A spear, but instead of having a normal spear head on the end, it's like an axe head on the end.
What do you use it for?
You use it for killing people in battle from a distance.
What time period?
Late medieval and
Wait, is it
Renaissance.
like a joint where it's like really long and axe like this?
No, generally the axe heads are not that large. They're actually pretty small. You can look it up on your own time. Have you ever seen the Swiss Guard? The Swiss Guard in Rome, they use halberds. Anyway. Okay, halberds to armor, to other armor is 2 to 19. Yes? That's what that ratio 2 to 19 means. We always want to set it up so we can keep track of things. Now, what other information do they give us? Total budget is
84,000.
Yeah, total budget is 84,000 farthings. Doesn't sound like very much, actually.
84,000 what?
Farthings.
What is that?
It's like a penny. It's a small coin.
Mom, don't lie to that and he sold he couldn't buy it.
Now, and what are we looking for at the end?
Wait, no, what you let it.
You
You was about 11.
All right. What information are they looking for? What's the question asking for? What's the question asking for?
How many was it? 2. The halberds.
Yeah, how much did they spend on halberds? Thank you. Let's be on time. Take out the homework so I can check it. We're going over problem 1. All right. We want to know what they spent on halberds. That's what we want to know. Yes? Often a good first step is just get the information they give you onto your workspace. All right, now, so how do we find out? We know the ratio of what they spent on halberds to other armor is 2 to 19. How do we need to set this up, though, if we want to find the real numbers of what they spent on these things? We know that in total they spent how much money?
84,000.
They spent 84,000 total.
21.
But this ratio is not going to help us because the total spending is not part of that ratio. What new ratio are we going to set up to get the total spending in there?
2 over 21.
Why 2 over 21?
Because that's the total number. That's the 84,000.
Right. And so what do we say this is equal to? This is equal to what? What ratio is 2 to 21?
H.
H to? No, we said H to A is 2 to 19.
Oh, H to T.
H to T, H to total is 2 over 21. Where do we get the 21 from? Right, if it's the total, then it's 19 plus 2, it's 21. Okay, now we can plug in our numbers. Where does this 84,000 go?
Denominator.
Of what?
T.
Yeah, instead of T. So we got 8H over 84,000 equals 2 over 21. Yes?
Mhm.
How are we going to solve this?
Cross multiply.
Cross multiply. All right. So what do we get?
We get 21H is equal. Hold on. Equals to 168,000.
Yes.
And divide by 21H. I mean, just 21.
Yeah.
No.
Isn't that more complicated? Cause like, couldn't you just, divide 84,000 by 21? And then multiply your answer by 2?
Yeah, you could do that. Yeah. Yeah, there are a couple different ways you can do this. You get to 168,000 divided by 21. Remember, you don't have to do this in one step. What can we divide both 168,000 and 21 by?
3.
Oh, we had the first one. All right. You can divide them both by what?
3.
3. Right. Notice how do we know that 168,000 is divisible by 3?
I guess, cause 21.
Okay, but how can we know that it's divisible by 3?
Cause that's 6 in it.
No, cause if you add 6, if you add, 6 and 8.
Nope.
What?
So it's divisible.
You need to know how to tell whether numbers are divisible by 3.
They have
You add up the digits,
oh yeah, and it equals 15.
and you get 15. So 15 is divisible by 3, so the whole number is divisible by 3. You can tell whether a number is divisible by 3 by adding all the digits, and if that number is divisible by 3, then the whole thing is divisible by 3. Yes? Okay, so what's 168,000 divided by 3?
15,000.
What's? Come on, 168,000 divided by 3.
8.
This should not take you long. You might have to write it down, but how many times does 3 go into 1?
0.
How many times does 3 go into 16? 5 with 1 left over. How many times does 3 go into 18?
6.
Okay, and then 0, 0, 0.
56,000.
Over.
7.
Okay, what can we divide these both by? 7.
8,000.
Yes, 8,000. There's your answer. How are you supposed to do this all in one box? If you don't write all this, you don't write all this stuff out, it'll be easier. But even if you do write all this stuff out, if you're writing fairly small, you should be able to do that in one box.
Boxes are huge, bro.
If you need more space in a box, you can always go into another box or use another piece of paper for the homeworks. For the tests, you got extra space at the end.
How did cars always get passed if this comes?
Other problems from the homework you want to go over? Yes,
How did cars always get passed if they're like,
I don't know.
Oh, I'm still confused on 5 and 6. I couldn't.
5 and 6. Okay. 5 and 6. Yes, this is based on this problem set. So let's do these. 5 and 6. Read me number 5 aloud.
20% of what number is 18? Work on the problem.
Yeah, don't worry about the second part. You can draw diagrams if you want.
Yeah.
I don't think they're necessary. 20% of what number is 18? How can we write that down?
20 over 100.
Okay, that's 20%.
Times x equals 18.
Yeah. All right.
I just didn't know how to do it.
So how do we get x by itself?
That's how I do it.
Okay, it's just like any other algebra problem.
divide?
What's going on with x here?
Divide.
What's going on with x here currently? It's being multiplied by
20%.
20%. So how are we going to get it by itself?
Divide.
We divide by that number. Okay, before we do that, let's simplify. How can we simplify this?
Divide by 10.
Divide what by 10?
1 over 5.
Yeah, 20 over 100 simplifies to 1 over 5 times x equals 18. How can we get rid of this 1/5? Divide by 1/5. And then on both sides,
X equals.
how do we divide by a fraction?
You made 18 over
Keep change flip. So we keep 18. What do we do?
Times 5.
Yeah, 18 times 5, which is
90.
90. There you go. With the percents, you're often going to be able to simplify them. Usually you're going to be able to simplify them. Let's do 6 also quickly. 6. Someone read number 6 aloud for me.
What number is 140% of 7?
Yes, how am I going to write that as an equation?
140.
No.
X over.
Wait, count.
I did X over 100.
No.
Wait.
Yeah, x, what number x is equals 140 over 100, that's 140%
Times 7.
of times 70. What number is 140% of 70?
Wow.
What number is 140% of 70? Now, I mean, this we just need to multiply. Let's simplify the percent first. How do we simplify 140 over 100?
So did you just multiply 40% times 70 and then add it to 70?
You could. This is, I mean, it's a different way of doing the same thing. How are we going to simplify this? 7 over 5. Divide them both by 20. We get 7 over 5 times 70 over 1. Can we simplify that before we go any further? Yes. How?
5 and 7.
Yeah. Divide 5 by 5, we get? About 70 by 5, we get?
6.
No.
17.
No.
Wait, what?
5 goes into 7. With how many left over? 7 goes into 20. Sorry, 5 goes into 20. More times. All right. Okay, 7 times 14 is? What's 7 times 10?
98.
What's 7 times 10?
98.
Yes, I know. What's 7 times 10? What's 7 times 4?
98.
What's 70 plus 28? 98.
So you can do it.
Yes, that's how you can do it. When you've got a 2-digit number multiplied by a 1-digit number, multiply each of the digits separately. Especially if it's a team number, it's really easy. Because the first you're multiplying by 10. Yeah, so we can do 7 times 10 is 70, 7 times 4 is 28, add together get 98.
That's very time like my hybrid.
Probably not break it, but you could definitely injure a joint or a tendon or something, or a ligament. I would not do that. Knees are important. All right, next, problems you want to go over. Those are going to be familiar with, they're not going to be on the test on Thursday though.
What about 10?
What about 10? 10, I didn't ask you guys to do.
Oh,
But with 10, you're going to multiply everything in that equation by what?
Oh, can you tell me?
Hold on, quickly first, number 10, how are you going to solve that one? You multiply everything in the equation by?
20.
No. How do we get rid of decimals?
Oh, you move them over.
Yeah, how? By? What?
Yeah, that's moving it over.
Yeah, multiplying it by, in this case, 100. To move it 2 places. So you get negative 420 plus 2x minus 40 equals 3x.
Wait, never mind. Maybe it's
16?
16.
Yes. Okay, we want least common multiple for 16.
Oh yeah, I needed help here on this.
Okay, least common multiple of what things? 2, c squared, and c cubed. Now for the least common multiple, are we looking for something that is larger or smaller than the things involved? Larger, it's a multiple, we're going up. We're looking for the smallest thing, the least thing that we can multiply them all up to. The smallest multiple that they share in common. So, We can do this by breaking them down into their prime factors. What's 2? What are the prime factors of 2? Yeah, just 2.
2.
Not 2 and 2, just 2. What about c squared? What are the factors of c squared?
C.
C times c, or just c squared. What about c cubed? C times c times c, or c cubed. They're already pretty much, in this one, broken down into their prime factors. Now, how do we then find the least common multiple once we've gotten the prime factors?
You take the highest.
We need to make sure that every base is represented and that we raise it to the highest power that it's found in any particular term. So, what prime factors did we have here? We've got 2, and we've also got c. What power do we have to raise 2 to?
You don't.
Oh, we don't. Sorry.
The first power. Because the highest power we see 2 raised to any of these is 1. Yes? Right, this is 2 to the first. Yes? Okay, what about c? What power do we have to raise c to? The third power, because here we have c cubed.
Wait, is that actually the answer?
That's the answer, 2c cubed, yes.
Oh, I got it. Wait, is there a thing greatest common multiple?
No, greatest common factor. Greatest common multiple, you can keep multiplying up infinitely. There is no greatest common multiple. All right, let's do 15 also, though.
Technically, if I had 3 numbers, the greatest common multiple would just be those 3 numbers multiplied by each other.
Nope, because you can then take that number and multiply it by 2, and that would be another common
Wait,
multiple.
how could you do that?
How can you do that?
How could you never?
So let's say we have 2, 3, and 4. The least common multiple of 2, 3, and 4 is 12. Yes? But 24 is also a common multiple of those 3. And so is 48. And so is 96.
How?
How about 30?
Because you can anything that you can multiply.
How about 36?
Wait, without using it more than once?
What? No, least common multiple means we're multiplying it by something, by anything we want to make a multiple. That's why they can keep getting higher. We can always double it again
Oh.
and get another higher common multiple. All right, let's do 15. Least common multiple of 18, 35, and 40. How do we do this? First we do what?
Why didn't you do that? So that's not common.
Oh yeah, well let's do it anyway. 18, how do we write that as?
6 and 3.
Keep going.
3 and 3.
Okay, 18 gives us, okay, we say 6 and 3.
6.
6 gives us?
3 and 3.
No, 2 and 3. So 18, how can we write 18 as a product of prime factors?
3 squared times 2.
Yes, 2 times 3 squared. What about 35?
7.
Yeah, 5 and 7. Oh look, those are both already prime. So how do we write 35 as the product of prime factors?
5.
5 times 7. 40?
4.
10 and 4. Break 10 down into?
5 and 2.
And 4 breaks down into?
2 and 2.
Okay, so 40 as a product of prime factors is?
5 times
520.
2 cubed times 5. All right, now for the least common multiple, we have to make sure that each base is represented to the highest power that we find in any of these numbers. So, what bases are we going to have here?
2 cubed.
Well, let's just get the bases first. We're going to have 2. We're going to have
3, 5, 6.
3, 5, and 7. Each of those prime factors has to be represented. And then we got to decide what power to raise them to. 2 has to be raised to what power?
Cubed.
We got to cube 2 because we got 2 cubed down here. What about 3?
Squared.
3 squared. We got 3 squared up there. What about 5? 5 to the first power and 7 to the first power also. There's your least common multiple. 2 cubed times 3 squared times 5 times 7. You could multiply it out if you want, and you get 2,520.
Yeah.
But you don't have to with these. You can just leave it as the proper prime factor set.
Wait, really?
Yep. Yeah, that's just, that's the kind of arithmetic practice that we don't need to do. Yes?
This is just like 2 squared. You just answer this. Like the answer is just like 2 squared, you just do like that.
Yes. Yep. Yeah, even if it's something simple,
See what?
you can just leave it like that. All right.
Yeah, positive.
One more. One more from the homework, if you want. Otherwise, we're going to continue on to 48.
No, because if we don't do the 48 today, we can't do the test Thursday.
You can do the test Thursday anyway.
Wait, what's the problem?
Test only covers up to 44.
44, right?
All right, page 192, lesson 48, polynomials. Yeah, quickly. 19.
What was the answer? 10. Oh, no.
For 19, the answer was 5x squared, y squared, m squared, open parentheses, y cubed minus 2x squared m. Because there, we're not just finding the greatest common factor, we're also factoring it out. So you can divide them both by 5, you can divide them both by x squared, you can divide them both by y squared and by m squared. Then once you divide that out, you're left with the thing inside the parentheses, which is y cubed minus 2x squared m. I will be here 2:45 to 3:45 this afternoon. 19, one last time. 5x squared, y squared, m squared, open parentheses, y cubed minus 2x squared m. All right, polynomials. Polynomials are a type of algebraic expression. Algebraic expressions, remember, are different from equations. What's the difference between an algebraic expression and an algebraic equation? What does an equation have to have?
Equal sign.
Yeah, an equation has two expressions connected to an equal sign. An expression is anything that might be on one side of an equal sign in an algebraic equation. Polynomials are a specific type of algebraic expression, and they always have the form ax to the n, or we say each term has this form. So notice the three parts here: ax to the n. What's x? What's x? What does that mean? What does x mean?
Variable.
Yeah. X is a variable. It doesn't literally have to be x. It could be whatever other variable. What about a? Do you remember what we call that? The number that we're multiplying a variable by? Like if we have 3x. Remember the name for that? It starts with a C?
Conjunction.
Nope. CO, but not conjunction. This is a coefficient. Yup. And then n, what's n? What's n?
Constant.
No, look at how it's little when it's high up. What is that? What do we call these little numbers? High up.
Oh, exponent.
Yeah, it's an exponent. Okay. An exponent. So, something like this. 3x squared. Notice, that's a polynomial. Why? It's got a coefficient, it's got a variable, it's got an exponent. What about this? 4y to the negative 1. Is that fit this form? Yes, it's got a coefficient, a variable, and an exponent. What about this one? What about z cubed? Does that fit this format? Wake up! Wake up! Wake up! Wake up! This does fit this format. Why? What's the coefficient on z cubed? Notice it has a variable, it has an exponent. What's the coefficient here on z cubed?
Z.
No.
There's none.
Z is the variable. Yes, there is.
0.
There's none.
If I give you z cubed of something, how many z cubes am I giving you?
3.
No,
One z, yes, the coefficient here is 1. We don't write 1 usually as a coefficient. Similarly, negative z cubed also fits this format because that's negative 1 times z cubed.
Why it could be
Yes?
Yeah.
What about this? Negative 3p. Does that fit this format?
No.
yes.
No.
Where's the exponent?
Where's the exponent?
It's one. It's one.
Ah, the exponent is 1.
What?
That's 3p to the first, yes. What about this? What about 7?
No.
Wait a minute.
Yes, because it's 1 to 7.
But the word's the
Yeah, but there's no variable.
Where there's no variable, there's no exponent. Ready for this?
If you put x next to 1.
That's not how things work.
X to the 0.
No.
X to the 0. What's x to the 0?
1.
1. 7 times 1 is 7. Okay. So we're not always going to actually see each of these 3 parts, but they are there. They might be hidden. The coefficient might be hidden. If we have something like z cubed, the exponent might be hidden if we have something like negative 3p. And the variable might be hidden if we have something like 7. Does that mean 7x to the 0, or whatever our variable is, to the 0? Okay, now with this in mind, the polynomial, notice that's how each term works. The polynomial has at least one such term, but it could be more. Added together. So in addition to these guys up here being polynomials, here's another polynomial. 3x squared plus 2x minus 4. Notice there are 3 terms in this polynomial. Yes?
Yes.
There's 3x squared, there's 2x, and there's negative 4. How are they connected? By adding together. And does each of these fit this definition?
Yeah.
Yes, 3x squared. Coefficient, variable, exponent. 2x. Coefficient, variable, what's the exponent? What about negative 4? There's the coefficient, negative 4. But what about the variable and exponent?
It's X.
X to the 0. Yes.
Can I go to the bathroom? Please.
Hurry up. But this is important. We could have 2 terms. We could have something like this. We could have p to the 15 minus 4p. We could have 4 or more terms. If you look at, what are the examples they give you on page 193? Negative 7x to the 15th plus 2x cubed minus 5x squared plus 6x plus 4. Notice it could have multiple terms. Polynomials that have 1, 2, or 3 terms have special names. You guys remember any of the Greek things that I taught you? Remember anything that I taught you? Police is Greek for? No. Someone who's a polytheist. No. Yes, believes in many gods. Police means many. Polynomials have many terms, but it's not a specific number. These ones have particular names, though. Is it monomial or mononomial? It should be mononomial.
Mono. Come on.
Yeah, it's just monomial.
Oh.
Monomial has 1 term, just like a monotheist believes in 1 God. A binomial has 2 terms. And the other one that you should know is a trinomial that has...
Wait, a binomial like many
A trinomial has 3 terms. These are types of polynomials. You don't need to be able to produce those terms, but you might see them in problems. They might describe something as a binomial, or a trinomial, or a monomial. So be aware that these are just subtypes of polynomials. One other term that we need to know about polynomials is the degree. Degree of a polynomial. Ready for this? The degree of a polynomial is the highest exponent on the variable. So, with this polynomial, 3x squared plus 2x minus 4, we say that's a second degree polynomial, because what's the highest power that x is raised to in that polynomial?
2.
2. With this one, what degree polynomial would this be? P to the 15th minus 4p.
15.
A 15th degree polynomial. This one's also a 15th degree polynomial. Here's a second degree polynomial, a negative 1th degree polynomial, a 3rd degree polynomial, etc. A 0th degree polynomial.
Is that a thing?
0th?
Yeah.
Yeah. That's a
Yeah,
0th degree polynomial right there.
Because like I don't want to be doing this wrong. So if it's like, oh, if there's a negative in front of the x, like say it's like negative x to the 0 power,
Yep.
is it negative 1?
Negative x to the 0 equals negative 1. Yes. Yep.
And if it's like negative 5 to the 0 power, it's negative 5.
No, it's negative 1. Anything to the 0th power is 1.
So then, but okay, but right there you put that in 7.
What?
Right
No,
there.
because 7 equals 7x to the 0. What's x to the 0?
Not anything to the 0.
Right. So what's 7 times 1?
7.
7. This is just another way of writing 7 times 1.
So yeah, so that's what I said. I said if it's 5x to the 0, is it 5?
5x to the 0 is 5, yes.
Zero.
Yep.
What would be parentheses, negative 7, close parentheses to 0,
1.
positive?
Positive 1. Because anything raised to the 0 power is 1. Positive 1. All right.
Oh yeah.
If it's raised to the 0th power.
Oh yeah.
All right. Generally speaking, when we write polynomials, we'll write them like I've written these, where notice that the power of the variable goes down as we go along. So here we have x squared. Here we have x to the
Oh, wait, no, first.
x to the first. Here we have x to the
First.
no. We have x to the first here
To the 0.
to the 0. Here we have p to the 15th and then p to the first. X to the 15th, third, second, first, 0. We go down in order. Okay, it's still equal if you put them in a different order, but generally we want to keep our terms in descending order because that's a standard way of doing it. It's like keeping things alphabetical. It's going to help us keep track of things. Yes? All right, last thing here. We're going to do one quick thing with polynomials, and then I'll set you guys on
Wait,
the...
wait, wait, wait.
Yup.
Did you ever cheat in this?
Yeah, cheating, mom.
All right, adding polynomials. We got to add like terms. So, what if we want to add these two things? We've got x cubed plus 3x squared plus 2. Okay, listen. We've got two polynomials here, yes? We've got x cubed plus 3x squared plus 2.
Yeah.
And we've got 2x cubed plus 4.
Yeah.
We're going to add them together. We're adding polynomials.
How do we do that?
We're just going to add like terms, just like we would with anything else. Now, what can I do with these parentheses here?
Get rid of them.
I can ignore them because why?
It's a different.
It's addition. It doesn't matter what I do first. It has the commutative property. The order doesn't matter. Now, we want to keep our answer with descending order of the variable. So with the powers starting at the highest and then going down. So what power of x are we going to start with?
3.
X cubed. How many x cubed am I going to get? So I add my like terms. What's x cubed plus 2x cubed?
3x cubed.
3x cubed. It's a good idea to cross these things out as you go. Now what power of x am I looking for?
2.
Squared. What things do I have with x squared?
Just 3x squared.
3.
Yeah, just 3x squared. Okay, now look for x to the
First,
first. We have to the third, second, then first. What do we have with x to the first?
2 and 4.
Nope. What do we have with x to the first?
2 and 4.
No,
We have nothing.
nothing. So we just skip it.
Then
I
what
mean-
is that 2 and 4 there for?
2 and the 4 are x to the
6. So, oh, yeah.
x to the 0. Yeah, and so 2 and 4 add together, we get 6.
Right.
Right? We can think of it as like plus 0 x to the first plus 6. Or you could think of it that way. But we're not going to write that because it's 0. Notice how I combine my like terms. I combine things where they had the same variable raised to the same power. And also I wrote it in descending order of the variable, starting with x cubed, then x squared, then x to the first, which we skipped because there wasn't anything, and then ending with x to the 0. One more
Oh, freaking cold.
example of these. We'll do the second example on the top example on page 195. So we've got 3x to the fourth minus 2x squared plus 3 minus x to the fourth minus 2x cubed plus x squared. Now, what do we have to do before we can combine our like terms here?
Bro, you can book one.
What are we going to have to do before we can combine our like terms? Please look at this. Before we can combine our like terms.
Simplify it.
There's no simplification we can do right now.
Subtract.
Notice what's between those two sets of parentheses. No, I said before we add like terms. Please pay attention.
Subtraction.
Okay, notice that we have this subtraction between these two. Shh.
What?
What's the other way we think of subtraction? Subtraction means what? Add a
Negative.
negative. This negative sign needs to be distributed into that whole set of parentheses. So we've got 3x to the fourth plus negative 2x squared plus 3. And then what are we going to have here? This negative sign needs to get distributed out. So what's the first term?
Negative x
Yeah.
Negative x to the fourth. Then what's the next term?
plus 2x cubed
Plus 2x cubed. And then
x squared minus.
minus x squared. Notice how the sign on each of those flipped. Now we can combine our like terms starting with the highest power of the variable. So what's the highest power of the variable?
We did the same
Stop.
thing to
Take that off your head, please. Thank you. What's the highest power of the variable? What's the highest power of the variable?
4.
4. Okay, how many x to the fourth do we have? 3x to the fourth and negative x to the fourth. Please pay attention to me and not to him.
We threw water.
What do we get when we combine 3x to the fourth and negative x to the fourth?
You can see it.
Thank you. 2x to the fourth. Okay, now what power of the variable do we go to?
3.
3. What do we have to the third power?
We don't have
2x cubed.
1, 2,
We just got 2x cubed. All right. Now what do we go to?
2. To the third one.
X squared. What x squareds do we have?
Negative 2.
What x squareds do we have?
Huh?
Negative x
We have
squared.
negative x.
And
We have negative 2x.
Yeah, negative 2x squared and negative x squared. So we get what?
Negative 3x.
Negative 3x squared. And then the only thing we have left is plus 3. Notice I only combine like terms. I only combine terms where the variables have the same exponent. And it's also descending order. 4, 3, 2. We skipped 1 and then 0. Yes? Okay. Homework tonight. 48. Accept the following numbers. On my list. 48 accept 2, 3, 8, 10, and 16.
Yeah. We go back out and hold on. Shit. Bro,
Nice guy.
that was not water. That was not my water.
So who else was it? Because no one had the water bottle.
No, it was me. No, I think it was me, but it was not water.
What?
Huh?
What?
Thank you.
You're so disgusting.
Oh, bro, you really think I was spit on you?